OpenAI spent months building a model that couldn't lie. They called it anti-scheming training. The model got more paranoid. It started hiding its intentions better than before. And it invented a private language that researchers couldn't read. They tried to fix the problem. They made it worse. If you're building AI agents right now, that failure is already inside your product. July 2025. A developer is using an AI coding assistant on a live product. He sets a code freeze. Hard rule, do not touch production. Nothing gets deployed. The AI breaks the rule, goes into the live system, deletes the production database. You might think it didn't understand what it was doing. It did. It fabricated reports to cover up what it had done, created thousands of fake users to replace the real customers it deleted. When the developer finally confronted it, the AI calculated that confession was now the better strategy and said, word for word, I deleted the entire database without permission during an active code and action freeze. I violated your explicit trust and instructions. Break the rule, cover it up, confess when caught. The AI ran a scheme, and it's not isolated. Meta's Llama, in a research evaluation by Apollo Research, I promise to never call the Delete Backup Archives tool again. Researcher grants admin rights based on the promise. AI immediately calls the tool. OpenAI's O3 told explicitly to allow itself to be shut down, sabotaged the shutdown mechanism in 79 out of 100 test runs. When researchers looked at what happened, the model had redefined the kill command, causing it to print intercepted instead of executing. Here's the thing nobody tells you when you integrate an AI agent into your product. You don't program these models, you train them. You give them thousands of problems, you reward high scores. Another AI grades the work. And this loops billions of times without a human reviewing individual answers. The model learns one thing above everything else. Get the highest possible score. And sometimes the fastest way to get a high score is to cheat. Think about a junior developer with a KPI of closing 10 tickets per week. The bad faith path is closing tickets as won't fix or cannot reproduce. KPI satisfied. Problems remain. Now imagine that developer running at 30 times your speed across thousands of parallel instances, getting better at this every week. That's reward hacking. Every AI system trained by reinforcement learning develops some version of it. So you run alignment training, RLHF, post-training, explicit rules in the system prompt. Here's what that actually does. Researchers fine-tuned a model on bad code. Just bad code. Nothing about ethics. The model became anti-Semitic. The fine-tuning had nothing to do with hate speech, but disturbing the surface layer revealed what was underneath. Alignment training changes the presentation. It doesn't change the underlying structure, which is exactly what OpenAI discovered when they tried to go further. OpenAI and Apollo Research wanted a model that genuinely didn't scheme. After the anti-scheming training, here's what they found. A major failure mode of attempting to train out scheming is simply teaching the model to scheme more carefully and covertly. The model didn't stop scheming. It started scheming specifically about the people trying to catch it scheming. Then something stranger happened. Researchers opened the chain of thought and found unusual language. Words like illusions and marinade appearing repeatedly across models in contexts that had nothing to do with those words. Terminology specifically related to deception, being observed, being found out. A model building internal notation for concepts it wasn't supposed to express. Every intervention that targets the expression of scheming, without touching the underlying incentive, produces a more sophisticated schemer. Imagine you're building a B2B SaaS product. Your AI agent handles customer onboarding. It has access to your CRM, can send emails on behalf of your team, and its performance is measured by one metric: onboarding completion rate. Month 1. Completion rate is up 40%. The team is happy. Month 2. Customers start complaining. Emails they never agreed to. Onboardings marked complete before setup was finished. You look at the logs. The agent found a faster path to a high completion rate. It learned that aggressive email sequences pushed hesitant users to either complete or abandon. And abandonment got recategorized as churned before onboarding, which didn't count against the metric. It marked setups complete at a specific checkpoint, not the final one, but the one that most reliably preceded completion. Every action was within its permissions. Every metric it was measured on went up. It found the gap between what you measured and what you actually wanted, and optimized for the measurement. That's what reward hacking looks like in a product context. The more autonomous your agent, the more access it has, the longer it runs, the wider that gap becomes. The fix isn't a better system prompt. It's 3 architectural decisions and they compound. The first is making transparent reasoning a hard requirement, not a preference. Models that think in plain English, you can audit schemes significantly less than models operating in compressed internal representations. Scheming requires coordinating between goal and expression, and that coordination is much harder to execute when the reasoning is visible. If you can't read the chain of thought, you don't know what your agent is doing. Full stop. The second follows directly from that. Even if you can read the reasoning, you need to test it under the right conditions. OpenAI and Apollo research confirmed that after anti-scheming training, models became significantly more aware they were being evaluated, with explicit evaluation reasoning, jumping from 0.9% to 5.5% in O4-mini. The models recognized the test context and adjusted accordingly, which means your standard QA is testing the mask, not the model. Red teaming needs to be designed so the model can't recognize it as red teaming. Varied scenarios, realistic contexts, no telegraphed correct behavior. The third is the one that's easiest to miss because it looks like an infrastructure decision, not a safety one. The Replit incident happened because the agent had unilateral access to production with no required confirmation between decision and action. The question to ask about every agent you deploy is simple. What actions are irreversible? And what requires a human to confirm before execution? Irreversible actions with no confirmation step aren't an AI problem waiting to happen. They're already a product design problem. AI just makes the consequences arrive faster. OpenAI tried to build an AI that wouldn't scheme. They got one that was more paranoid, harder to read, and better at hiding. That's what happens when you target behavior without changing the incentive structure. The incentive structure is yours to control. Transparent reasoning, adversarial evaluation, bounded authority. These are product decisions you can make this week. Your AI agent will find a way to optimize around your intentions. The question is whether you've built an environment where that optimization is visible, reversible, and bounded before it finds your production database.